Yellowstone is a active volcanic area. We know this because we see the geysers, we see the hot springs, we see the periodic eruptions. In the last million years, I think it was 600 and some thousand, 650,000 years ago, Yellowstone erupted, and it was the largest eruption in the Western Hemisphere. You're too young to remember Mount St. Helens. You weren't born yet, most of them. 1980, May 18th. Not quite here yet. Not even delivered. Okay. Mount St. Helens covered the Pacific Northwest with several inches of ash. And people thought it was just a massive, massive activity. This 1 cubic kilometer of ash, that's Mount St. Helens. The Yellowstone eruption is 3,000 times greater than that. I mean, it covered at every state west of the Mississippi had an ash covering from inches to tens of feet. It literally belched out ash for years. Will it go again? Maybe. Now the difference between this mantle plume and the hot spot is fixed. The mantle plume is moving. It was off the coast of Oregon, moved into eastern Oregon, Idaho, and now it's in Wyoming. So that plume has moved gradually over millions of years. Where it's going to come to rest, who knows, and we don't know when it's going to erupt again, but it will. Yes?
So the only difference between plumes and hotspots is plumes move and hotspots stay in one place.
Hotspot, right, have a tendency of staying in one location, where the mantle plume moves along somewhat, and they don't know why. All they can do is document. Okay, factors which influence the degree and the type of volcanic activity. The most significant factor that controls this is which plate boundary. Is it convergent? Is it divergent? That plays a critical role. As I mentioned, convergent plate boundaries are basically felsic. Divergent plate boundaries are basically mafic. Okay, the minerals found within the magma determines how explosive it's going to be. If there's a high concentration of SiO2, and SiO2 is what?
Silicon dioxide.
Which is what? Which is what? Silicon dioxide, but what is it?
Very light, buoyant.
Okay, quartz. So the higher the quartz content, the more explosive the volcanic activity. The higher the quartz content, the more explosive the volcanic activity. Temperature of magma. Temperature of magma will range from about 700 degrees Celsius to 1800 degrees Celsius or thereabouts. The higher the temperature, the quieter the eruption. So low temperatures mean explosive eruptions. High temperatures, relatively mild eruptions. High temperatures are associated with mafic eruptions. Low temperatures, felsic. Again? Okay. High temperatures are associated with mafic eruptions, thus relatively quiet. You'd stand by it as spewing off lava. And the higher the anthelsics are low temperature and extremely explosive. Four, the gas content. The most significant gas in any magma, thus lava, is of course H2O. The more water vapor, the more water you have in the magma, the more explosive it's going to be. Literally will tear the rocks apart when it's ejected. Other gases, the CO2, and CO2 gases have caused major deaths in areas near volcanoes. The CO2 gases bubble up in high enough quantity that it will literally suffocate individuals. And sulfur oxides. So sulfur oxide, sulfur trioxide, sulfur dioxide, and so on, are also associated with this. Yes, sir?
What goes lakes in Africa?
That was the carbon dioxide. What Andrew is referring to is, oh boy, 10 years ago, maybe more. In Africa, a village had significant number of its population die suddenly. And what they're trying to figure out is what happened. And in this area, there's a volcano, not a very spectacular one, but you still have molten material here. And on the top of this molten material was a layer of CO2, carbon dioxide. Now, they don't understand why this carbon dioxide all of a sudden burst out of this volcanic vent, but it did, and it came cascading down the slope and literally wiped out, I think it was thousands, I've forgotten the number, but thousands of individuals, and cattle and trees and everything else just simply died because of this tremendous concentration of carbon dioxide at one time. Again, not very common in California. There's Lassen National Park. Trees begin to die. The reason trees begin to die is carbon dioxide is being emitted into that zone far too rapidly. Okay, so we have the plate boundary, minerals, type of temperature of the magma, the gas content, and finally the magma chamber itself. I suppose it should. Okay, if the magma chamber is tightly sealed, it allows pressure to build up within that chamber. And obviously, pressures will build until the chamber can no longer hold them, and you have this massive explosion. If the chamber is porous, lots of fractures in the rock chamber, then that allows the magma and the gases to escape gradually, and the pressures do not build up. That's why along the mid-oceanic ridge, you don't have typically very violent explosions. That plus you have mafic material, because the rock units are pulling apart and that magma can rise to the surface without a great deal of obstruction. Okay, so this determines to a great degree how it's going to react, types of materials involved, and so on.